All right, fantastic. Well, thank you all. I'm doing a short 20-minute talk here on the impact of managed services on modern software architecture. And this talk is really meant to make you think about how the world changes in software architecture with technology as technology advances, and how we are very bad, as I see as an industry, at really understanding how to properly use use new technological advances in terms of building software more efficiently, more effectively. My experience has been that if you do learn specific new technologies quickly and effectively, you can be lead much better and more effective software development teams, building much better and more efficiently. That it is possible to be cheaper, faster, and better, and that most people don't, and they don't understand this. And this talk is designed to have all of you just think about this problem that we have with some specific examples. So I want to start by pointing out that there is no continuing education requirement in software development. And it's shocking to me because in professions like, certainly in the United States, to be a doctor, to be a lawyer, to be a real estate agent, so to be someone who just helps people buy and sell homes, a practice of which that really has not meaningfully changed for more than 100 years, and certainly not in the last 60 years, you need to have regular continuing education credit. But you don't have to do this to build software. And in fact, the traditional path that happens that I see is you go to college, you learn some things in college about how to develop software, usually kind of the latest, most interesting things. Then you start working and you use those things. And then suddenly 10, 15, 20, 25 years later, you're largely learning the same practices and the same techniques that you did right out of college. And you don't really have a good understanding of how you could most effectively use newer technologies. And so you get a lot of just people who don't understand and who spend a lot of time and energy pushing back on what is new and what is now possible. So I think the best way to really understand this problem is in thinking about the impact of managed services. Now, I'm specifically saying managed services here because I want you to think about everything that is managed. I want you to think about this trend that we're going on, where 25 years ago, most software development was being built for individual machines, maybe in a client server context. And now we have all of these amazing services that we can leverage, that we can attach our software to and use as a core base of our application. And so as we have these available, the way that we think about building should be much different. I would argue that in most cases, people are moving very slowly and are kind of 10 or 15 years behind on average what is actually possible. So a little bit about me. So I have a book coming out called Serverless as a Game Changer. And if you find any of what I'm talking about here interesting, this book goes into much more detail about serverless software architectures, good ones, bad ones, why to use them, and a connection between serverless software architectures and more modern ways, at least in my experience, that they enable one to run software product and software development organizations. Over the past 25 years, I have built a number of businesses from scratch. And you can see a couple here. One other one might appear, but I built a data business called BuildFact that collects all the building permits in the U.S. And sells them to hedge funds and insurance companies. I built software as a service in the commercial real estate space. I built software as a service in the government software space. And at the moment, I am co-founder and CTO of Branch, an insurance company in the US that sells home, auto, renters, umbrella, and condo insurance currently. And yeah, here we go. Here's all my other aspects of it. And so I have a lot of experience going from zero to profitability in a number of companies. And I also have quite a lot of experience in taking over teams in larger organizations that are using different technologies as my companies have been acquired into larger companies. And so what I want to talk about in managed services is first, when I say serverless or when I say managed services, what do I mean? There's a lot of definitions of serverless. My book talks about a number of different definitions that I think are helpful. For the purpose of this talk, I want you to think about managed services as there are no server operations you're doing at all. There's no patching. You're not worried about any individual machine, and it's not your uptime. So if it goes down, you can't do anything about it, absent like you configured it so badly that it's wrong. But essentially, if you set it up and it's working, if it goes down, it's somebody else's responsibility. So if we can have this conception of there are now, today, lots of managed services that are true, that where this is true, right? And here's a great and probably the best example, or at least the most universal example in the US, is Twilio. And so you write your application, right? And I think everybody understands how to use Twilio. It's a very simple way to implement managed services. You write code, you connect to Twilio, and Twilio will do things for you, or really does kind of one main thing for you. The main thing that Twilio does is it sends text messages. It also receives text messages, and it can do a few other things with telephony. Developers really understand this. This makes a lot of sense. This fits into existing models that developers have. So it is when as an industry we decided we needed to do integration and to do SMS work, some companies went and bought a lot of boxes with telephony cards and tried to implement those in like a co-location facility. But most companies said there's got to be some better way to do this. And Twilio did a great job, was out front, and had this wonderful way that you could make API calls and it would handle this for you. And so you can make API calls to Twilio and you can set up webhooks so that Twilio will ping you back. Again, this works great. This is very simple. Developers really understand how to use Twilio. If you haven't used Twilio, you should try it if you need to do any sort of SMS work. But here's the problem. When you start getting more complex with your managed services, and so let's think about this kind of architecture in managed services, which is where I think a huge amount of the gains can be made in serverless or managed services. People have a very hard time adapting their worldview of how to build an application to leverage the managed service. So this is a model of using AWS AppSync, which is a GraphQL front-end API hub as a service. So first of all, as soon as I say that, like if you've never used AppSync, I'm not going to have a really great way to explain it to you. I'm going to have to give you a lot of examples of that. Most people don't really understand how amazingly powerful AppSync is. The best anecdotal story I can tell you about AppSync is that I don't know anyone who builds software repeatedly or is in a software consultancy that builds applications that have web front ends that are, in the standard 80% of applications. I've never met anyone who has built an application effectively with AppSync and then didn't have it as their default for everything going forward. And Jan Kui, if you're familiar with him, has run a consultancy, built a lot of applications in a lot of environments, and he didn't understand AppSync originally and didn't really have a sense of why is this a big deal. Finally built a couple applications in AppSync and said, this has changed how I think about building software. This is really what I'm talking about in when you have new technology, there is a need to really understand what it is and really take a step back and ask, how does this change how I might build software in total? And so, what is possible then with AppSync and with this sort of architecture? So, we've got Dynamo, a highly available, highly scalable database. Lambda functions, again, completely scale to zero. S3 scale to zero. All of these are pay per use, scale to zero, sort of infinitely scalable, and they don't go down. We're going to get to that, and I'm happy to get questions about this statement that they don't go down, but effectively they don't go down. And so when you have these, it should dramatically change how you build things, because in general, if we think about the evolution of software architecture into the cloud, one of the things that the cloud really did was accelerate this view of microservices, but it also made us paranoid in the microservices architecture context, where we said, well, every microservice really needs to have its own data store, because if you have a bunch of microservices that are theoretically separate, but are talking to the same data store, they're not isolated enough. And you just created a distributed monolith that is highly problematic. You're not actually getting the gains that you think you're getting from it. And so we built these rules, right, and these heuristics that are like, if you've got a microservice, you need to isolate out each individual data store to microservice. Is that really true if your data store never goes down? If it just scales infinitely, is that a true constraint? People don't ask these questions. And so what you get is one of the best examples of this phenomenon of people not understanding how to use technology and not applying what we could do with managed services to modern software architecture, is this paper that came out in the last few weeks from the Amazon Prime Video team. And the Amazon Prime Video team published a blog post in which they essentially said, look, we built a serverless architecture, and what we found was it was bad. And so we ended up rewriting it, and it's not serverless, and it's way better now. And so there's been this has created a lot of additional articles, certainly within the serverless community and space, but more broadly as well. And then you have people like David Heinemann Hansen, who built his email service, Hey, as a serverless service, or on the cloud, and then repatriated it to a data center when he realized that what he had built was not working very well for him. And he is now on his own little crusade of why serverless is terrible. But the really interesting thing about this paper to me, as someone who has built serverlessly since 2015, is it's pretty painfully obvious, and it falls, and this architecture falls into this general category of people who are senior solutions architects who understand how to build software and who just read a little bit about serverless, don't play around with it, and then just build something that is, from the beginning, we could know is not going to be a good architecture. And the central problem that people have when they come to serverless is they think of an application as having, okay, if I've got a monolithic application, I've got a bunch of functions in it. And so if I'm going to serverless, all I'm doing is taking this monolithic application, I'm taking each of these functions, and each is a Lambda. And the Lambdas will all call each other. And then that'll be wonderful, because they'll each scale, and then I can build this parallelization net. This is, nobody who builds serverlessly would build this way. This is the idea that you would take, I've got this paradigm, and I'm just going to kind of map it directly in to new technology by running it, in a way that, at first glance, seems to make sense. It's not an effective way to use it. It's not an effective way to think about it. But yet you get this, and this is in my experience, the most common outcome from giving senior solutions architects, senior architects, and having them look at serverless. They don't ask, how should I rewire my brain for this? So The central concept then that I want you to have in mind is that if you have a new technology, in this case managed services, but any new technology, if it's relatively simple, it does one thing. I think in general, people are very good at incorporating it. However, if you have a technology that really can fundamentally change the way you build software, then I think it is very likely that the amount of work that's needed to understand it and use it effectively is significant. And you get a gap, a really strong gap between people who have understood how it changes the paradigms versus people who are still building the way that they have. So, to start you on your journey within here of managed services, you should really ask this question: that what happens when your state services don't go down? It, I can tell you, having built on, I'll name a couple of services. So DynamoDB, S3, Algolia, which is a search index that's far better than Elasticsearch and is a fully managed service. Cloudinary, which manages images and image manipulation. These services don't go down. They scale infinitely. And so there can certainly be cost constraints in them. There are cases you may not want to use them for cost. But if your state services don't go down, the entire concept of how you should manage service, the entire concept of how you would build with microservices goes out the window. All of the constraints, or many of the constraints that were driving why we were building microservices in the way that we have, go away. It should fundamentally change the way we think about how we build things. We now have a storage service or state-based services that we can just rely on and that we can access via API, or even better, our front ends can access directly. So another example of this is Algolia is a search index, again, sort of like Elasticsearch, but much better. But it has actually really good fine-grained access controls. And you can pass from your backend, once you have an authenticated user, you can pass a token that's custom to your user that only has the permissions they need on that search index. And then that front end in React and Vue, whatever, can just query directly that search index. And it's like a sub 10 millisecond response time. It entirely changes the type of experience and search performance you can get. And it has nearly zero coding. In terms of the amount of code you're writing is just absolutely minimal because it just works. So this is the graph then I want to leave you with, and I'm happy to answer a question. When I think about the impact of managed services on software development and modern software architecture, what I really think about is this blue, standard normal curve. I think is when I think about software development 15, 17 years ago, I think about we were all about as efficient as we could be. We had a bunch of inefficient practices, and the technology was all fairly similar, and you couldn't get a lot of gaps. What I think has happened and what I have seen is more of this this gold-colored curve, which is that now there are ways of building software. There are ways that when I built BuildFacts, it took me a team of 5 developers. It took about 2 years to get those production systems up, and we had a sort of the constant bill in today's terms would be something like $500,000 a year for what that hosting is. If we were to build that same thing today with managed services, one developer, maybe 3 or 4 months, and with a run rate of probably $500 or $600 a month. And so, and I mean, and I know, and I've built these things, and I have tried to change as I've gone forward. And so, if we are not good at learning new things, if we are not good at understanding what new technology can do, we are keeping ourselves and holding ourselves back as development organizations. And so, I think just as in we need to understand how to evolve our architectures over time and start simple and iterate. We also need to understand how to learn new things and learn new technologies and change the way we have been built. So that's my thought and my idea for you to ponder. Book coming out this year, Serverless as a Game Changer, and then happy to take questions.
Thank you so much, Joe, for joining us online. So you can't hear the applause that the co-authors give you, but you're with us here in spirit, and that's amazing. I have two questions that I think we can manage in the remaining time. The first is, if I have 200 user entry points to my application, does this mean that I have 200 separate JavaScript files and 200 AWS Lambda deployments?
I'd talk really briefly about something like AppSync, or I mean, Firebase has another model that's really great. But yeah, this is like a classic problem of no, absolutely not. Um, AppSync works by defining a GraphQL schema, and you could have a single Lambda, single JavaScript file that's handling all 200 entry points. And in fact, we probably have something like 200 entry points, and we have probably like 10 Lambdas that handle those. But no, I think that one-to-one relationship is exactly this problem of people not coming to the new technology and asking what's the right way to use it.
Okay, thank you. And the second question, I hope you can answer it briefly. What do you say that? Why do you say that the team size of a team building a social network serverlessly approaches zero? How is that possible?
Yes, great part of my book. Uh, what we have seen over time is that it does. So there was a social network. Uh, why am I blanking on the name? But where you could just poke people, and it was built by one person with a serverless backend. And so I think all of the things that made building a social network hard in Friendster days have become incredibly easy because we can scale and we can scale those communications back and forth between people, and that's really not the problem. And you know, it, you know, the my expectation is that we will see, and you can do this with Blue Sky, I guess, as well. That I think they have like 3 or 4 developers. So on the core application, they have one mobile app developer. So I mean, I think you see this as well in as people are launching things. I mean, they're still really inefficient people, but what is possible out there is very small and very efficient.
Okay. Um, Actually, we're out of time, but there's one more question I need to ask. I didn't ask it myself, but how to avoid a distributed ball of mud with serverless?
I think if you look at the like if you looked at the AppSync class that Jan Kui has, or you just look at what some of again AppSync or Firebase, I think if you look at what those applications look like, you'll see that there's nothing remotely close to distributed ball of mud. I think that the functions calling functions calling functions calling functions are the things you should avoid and are anti-patterns.